Good afternoon, everyone, and a warm welcome for today's talk. We know that every month we organize certain programs like online webinars on different topic related to space, science, and technology. So this month we'll be talking about on astronomy. And to talk more on this subject, we have with us a special guest, Pratyaksh Malhotra. Pratyaksh, I welcome you on behalf of Nehru Planetarium, Nehru Memorial Museum and Library, which is now known as Prime Minister's Museums and Library. So, as we have decided that today we'll be talking about A for astronomy, and uh, during this webinar, during this talk, we'll try to touch various aspects of cosmos, and we really encourage your participation. If anything you have in your mind, you can drop in your you can write to the planetarium. Also, you can drop your comments or questions in the chat. So about Pratyaksh, I would like to tell you that Pratyaksh is an amateur astronomer, astrophotographer, and presently he has started up his own venture, which is Science Genie, in which they are popularizing space, science, and technology. In short, if we talk about STEM education, various programs are there for school students and people who are interested in this subject. So I also request Pratyaksh to quickly just tell everyone about the organization as well, so that if anyone is interested, they can get in touch with you for that. So in past also, Pratyaksh has helped Nehru Planetarium for various programs. We have done like various virtual walks related to planetarium, and also here helped planetarium in popularizing the space science and basically astronomy education. So I welcome Pratyaksh once again on this platform, and we look forward for this interesting session related to A for astronomy. Over to you, Pratyaksh.
Very thank you, ma'am, for a wonderful greeting for me. And it is my pleasure to serve planetarium as an astronomer because since my childhood I have visited planetarium, but every time I visited I was thinking that let's do something for planetarium. Now I'm very honored to like do something for my planetarium and the astronomy subject which I am in love with since my childhood. So, as ma'am told, I have started my venture as Science Genie, in which we are dealing with STEM subjects like robotics, astronomy, electronics, mechanics. For that, I have mentioned my website and will mention it. You can visit it, sciencegenie.in. So, for now, let's start with our presentation because that is our main goal. So, can I start, ma'am?
Yes, please.
Okay. So, our presentation is A for astronomy, and myself Pratyaksh Malhotra, Science Genie, my website www.sciencegenie.in. You can visit and have a look. So let's start with our presentation. Okay. So first of all, everything starts with an introduction. Astronomy, often hailed as the gateway to the universe, is a captivating and profoundly influential field of scientific inquiry that has intrigued humanity for millennia. At its core, astronomy is the study of the celestial objects and phenomena that adorn our night skies, from the dazzling array of stars and galaxies to the enigmatic worlds of our own solar system. So basically, astronomy is everything which has like which has carved our whole history, ancient history, from ancient history to our modern history. Astronomy is the backbone of our scientific research and everything we can say. So first of all, like how all this started. In this slide, I would like to tell you about that origin of our universe, because astronomy somehow is connected to the origin of our universe. How this universe we are seeing, the materialistic world, how this all originated. Okay, so there are some hypotheses and some proved theories I would like to discuss about. The first theory regarding the origin of universe, such as the Big Bang theory, posit that cosmos began as an immensely hot and dense singularity around 13.8 billion years ago, rapidly expanding and cooling to form the universe as we know today. this is the first theory and the most like acceptable theory, because it has some scientific evidence which we have seen, such like as cosmic microwave background and all these things which we have observed, that okay, some from some singularity universe has formed. The next theory is the oscillating universe. Our Vedas, in our Vedas, basically, this is prescribed. Like the universe is not originated first time. It is going into infinite cycles of expansion and contraction. And the next theory is, in contrast, the steady state theory suggests that the universe has no single origin and continually generates matter to maintain a constant density. But as we all know, these theories offer different perspectives on the universe birth. But the Big Bang theory stands as the most widely accepted explanation supported by significant empirical evidence. As I told you, cosmic microwave background is the basic and the most important evidence of these this among these all. Big Bang theory, the accepted one. Okay. So let's go for our next slide, that is history of astronomy. It's a worldwide overview which I am giving here. The history of astronomy is a journey that spans millennia, reflecting humanity's insatiable curiosity about the cosmos. Ancient civilizations such as the Babylonians and Egyptians tracked celestial movements for practical purposes like timekeeping and agriculture. So they were using astronomy, that okay, now we are seeing some particular constellation in the sky, okay, now it's time to harvest this crop and that thing. So this type of way they were keeping record using the astronomy. However, it was the Greeks who laid the foundation of the modern astronomy, with thinkers like Aristotle and Ptolemy proposing geocentric models of the universe. Okay, so what they did, the geocentric model now came into existence. In this model, as we know, that geocentric means that the Earth is the center, and Sun, Moon, and everything is moving around our Earth. So it was prescribed in Bible also, that Earth is the center of our universe, of our solar system, basically, and all things are moving around. But in the Renaissance, Copernicus challenged this geocentric view introduction as heliocentric model, in which he said that Earth is not the center, but Earth is moving around Sun or some other very heavy mass or heavy, like some other big system. Earth is the part of the big system, not the center of the big system. So in 1546, this date you should remember, it is said heliocentric model in 1543, setting the stage for the scientific revolutions. And Galileo's telescopic observation confirmed the heliocentric theory, while Kepler's laws of planetary motion provided crucial insight. Why I asked you to remember this 1543 date, in the next slide we'll discuss. So here is the ancient Indian astronomy that we are about to discuss. So let's start with it. So ancient Indian astronomy, known as Jyotisha, holds a rich and influential history that spans thousands of years. Here are some key aspects and contributions of ancient Indian astronomy. Vedic period, around 1500 to 500 BC. Early Indian astronomy was rooted in the Vedas, the ancient sacred texts. Vedic scholars observed celestial objects and their movements, which were crucial for rituals and calendars. They had a concept of nakshatra, lunar mentions, for timekeeping. Okay, now the date is about to come that I asked you. Okay, as you all know, Aryabhatta, around 476 CE, Aryabhatta, one of the most renowned Indian astronomers who wrote the Aryabhatiya, which represented a heliocentric model of the solar system, accurately calculated the value of pi and provided the method for solving astronomical problems. So Copernicus gave that idea of heliocentric in around 1546. But now we are seeing that Aryabhatta in 476 CE gave the idea of heliocentric model 1000 years, 1100 years earlier than Copernicus. So you can see how advanced our ancient astronomers, Indian astronomers were. Another contribution is of Brahmagupta. Brahma Supta Siddhanta, contained valuable contributions to mathematics and astronomy. He introduced the concept of zero. In my childhood, there was so much confusion for Brahmagupta and Aryagupta, Aryabhatta. So much of some teachers told write Aryabhatta in zero, and some teachers told that write Brahmagupta. So now this is the final thing. Brahmagupta gave the concept of zero, negative numbers, and algebraic solutions for astronomical equations. Okay, so Varahamira in 6th century, Varahamira's Panchasiddhantika synthesized five astronomical systems and provided methods for planetary position calculations. His work was influential in Indian astronomy and Arab astronomy. Now, this Surya Siddhanta, there's a very good exhibition at planetarium also regarding the Surya Siddhanta and some book pages. You can visit planetarium for this. You can see that pages also in which the ancient Indian astronomical text dating back to around 400 CE provided insights to the solar and lunar eclipse. So say there are actually the diagrams and everything in Sanskrit. It's written how eclipse is happening and what are the like how you can predict the next eclipse and all that things. The Earth's diameter and the trigonometric calculations. So in 400 C they gave these things. And Aryabhatta II in 10th century expanded on the earlier Aryabhatta's work, further refining calculation related to planetary motion and eclipse predictions. Now, these are just some of the contributions I am giving. There are n number of contributions. So last one for here is Kerala School of Astronomy, 14th to 16th century, located in the southern India. This school made significant contribution to calculus, including infinite series and trigonometry. Madhava, Nikanta, Somyaji, and other played key roles. Okay, so let's start our cosmos journey. This was the ancient histories and every contribution I was telling contributions. Now let's a brief intro for our solar family because our journey will be starting from our solar family to our stars and every galaxy we are seeing. Okay. So the family is a captivating and intricate cosmic neighborhood that has fascinated humanity for centuries. Comprising the Sun, eight major planets, their moons, asteroids, comets, and a vast array of celestial objects, it is it offers a glimpse into the profound complexities of the universe. At its heart, the Sun, a colossal, searing ball of gas that has provided the life-giving energy of our entire system. Orbiting the Sun in order of proximity are the rocky terrestrial planets Mercury, Venus, Earth, and Mars. So these four planets are your rocky planets. These inner planets are characterized by their solid structure, and Earth in particular stand out as a heaven for life. Beyond the inner planets lie the asteroid belt, a region populated by rocky remnants from the early stage of solar system formation. The galaxy giant Jupiter, Saturn, Uranus, and Neptune follow each unique in its own right, boasting intricate ring system. As we all know, Jupiter and Saturn particularly has the most beautiful ring system. Even Jupiter, Neptune is also having some ring system. Uranus is also having ring system, but the most beautiful ring system is of our Saturn. The solar system also hosts an as- assortment of moons, with some like Saturn's Titan, Jupiter's Europa, harboring potential for extraterrestrial life. So, some moons like your Saturn's Titan and Jupiter's Europa are known to be like they may contain life because there are some icy structure beneath where water is like said to be there may be some presence of water and other compounds that may host life like water. Okay, such like methane and that type of compounds, organic compounds. As we venture beyond the Pluto's orbit, we enter the Kuiper belt, a region teeming with icy objects and the hypothesized Oort's cloud, a vast distant reservoir of comets. So it is said that all these comets that we see, like Halley's comet and so many comets that we are seeing, are actually coming. They are actually the visitors from the Oort's cloud, a hypothesized cloud where it's at the edge of our solar system, from where all these comets and all these visitors that we are seeing of our solar system are originating. Okay, so with this, a small introduction to our solar family we have finished. Okay, so this is actually this slide actually is life cycle of a star. As we all know, we are all very interesting. We are all very interested to know about stars. Like some stars are black holes; they will form some black holes. Some will form neutron stars. But this slide will give you the a whole summary that okay, what all things is happening. That if we want a star to become a black hole or to a white dwarf, what are the essential features? So first of all, our journey is starting from a stellar nebula. Remember, the star which we are seeing now are actually they are actually formed from a nebula which was which was formed due to the death of a previous star. So the sun which we are seeing in our night sky is actually the product of a old or a parent star of sun. So this way all this happening, like we humans are getting we our parents are giving birth to us, same way there is a parent star from which all stars that we are seeing are getting birth. So first of all, an old star will die and a nebula will be formed. Okay, so there are two steps. A stars with solar masses less than the 8. Solar mass here means our sun. The stars with like 8 suns, if we take sun mass and multiply it by 8, and if the mass is less than that 8 solar masses, we call it as average star. What it will become in the main sequence or in the adulthood, it will be like an average star. Okay, then it will go into the red giant phase when it will become old, when it will start fusing helium and then carbon. Okay, and then when after the carbon, when it is not able to fuse it completely, it will suddenly shred its outer layers and it will become a planetary nebula. And from this planetary nebula, at its core, the mass which is left out of the star, a white dwarf will be formed. Okay, and if stars are having mass more than the 8 solar masses, what will become? It will be a massive star in its adult age. It will become a red supergiant in its old age. Okay, and it will start to fuse heavy elements, like it will try to fuse carbon also. Then carbon, then argon, then after that argon, when there's a stage of your iron. Okay, iron is the poison of these stars. The moment the core is forming iron, it is not able, it will act as a poison and it will go into a supernova explosion and it may form a neutron star and a black hole. In next slide, I'll tell you the exact procedure, how it is getting how it is getting done, all these things. Okay, so first of all, let's talk about little bit detail about your white dwarfs. So Chandrasekhar limit is established at a point when the mass at which the pressure from the degeneration of electron is not able to balance the self attraction of the gravitational field. The limit that has been established these days is 1.39 solar masses. So Chandrasekhar limit tells us that if the mass of a white dwarf is more than this limit, 1.39 solar masses, it will it will become a neutron star or a black hole. So this is the limit. More than this limit, this mass 1.39 solar mass, if a white dwarf is having, it is not able to, it will not become a white dwarf, it will become something like black holes or neutron star. Okay, so now what is the degeneration that we were talking about here of electrons? Okay, so degeneration is a quality of matter occurring when it is compressed to the point that electron fills the lowest quantum states, forming electrons degenerate matter EDM. The Pauli exclusion principle, as we all know, dictates that within a sufficient small volume, at most one electron can be present at a specific state. So, what is this happening? That it will hold the structure of the core, that it is having electrons. As we all know, matter is having electrons, protons, neutrons. So this core is having electrons, and it will try to hold the core at a level where that this polio exclusion principle is applicable. Okay, at a small amount, this one electron is present at a small volume. Okay, it will hold up to that, so this will form the basis of the white dwarf. But all direct mass determination of actual white dwarfs have resulted masses less than the Chandrasekhar limit. Okay, a star that end its nuclear burning lifetime with a mass greater than the Chandrasekhar limit must become either a neutron star or a black hole, as I told you. So, if any of the star core, which is about to form a white dwarf, is ending up with mass more than 1.39 solar masses, it will become either a neutron star or a black hole. Okay, so this is very important thing that we should remember. Chandrasekhar limit, which our Indian scientist Mr. Chandrasekhar. Okay, a typical white dwarf is about as massive as the sun, yet only slightly bigger than the Earth. So it is as massive as our sun, but slightly, just slightly bigger than our Earth. So you can see how much density of material, that matter, is there in the white dwarf. Okay. Now, if the core has a mass less than about three times that of our sun, the collapse of the core may halted by the pressure of neutrons. That is even more extreme than the electrons pressure that supports white dwarf. In this case, the core becomes a neutron star. The sudden halt in the contraction of the core produces a shock wave which propagates back through the outer layers of the star. Now, this is for the stars more than the three solar masses. Okay, so which propagates back out through the outer layers of the star, blowing it apart in a core collapse supernova explosion. So what will happen, which is having mass like about three times that of our sun, okay, it will less than three times less of our sun, it will go into the supernova explosion. Okay, but if the solar mass of the core when it is dying is more than the three solar masses, it will, even neutron pressure is not able to is not sufficient to withstand gravity. So try to understand that if our solar, if the core that is left out of the dying star, okay, if it is having solar masses less than three solar masses, it will become a neutron star. And if solar mass of the dying core or the left out core is around more than three solar masses, it will become a black hole. So these are the some key points that we have to remember for astrophysics of stars or the biography of stars. Okay, in the theory, a singularity describes the center of a black hole, a point of infinite density and gravity within which no object inside can ever escape, not even light. So, as we all know, as we discussed, that from singularity our whole universe came into existence. But here it is said that inside the black hole or at the center of the black hole, a singularity is there, which we all know that it is beyond actually physics, that how infinite mass can be at a point, can be present at a point. So that is the biggest like miracle of black holes. That's why they are the most widely asked objects, like widely discussed object of the cosmos. Okay, so now we are about to start with our slide, which is the one of the most fundamental question that we are asking. What is life? How it came into existence on Earth? Okay. The state of being conscious is termed as being living. If I am living, I am breathing, I am conscious, I am responding. Okay. So that is termed as living. Very easy. But according to scientists and philosophers, life came into existence in the following ways. On Earth, basically, they are saying that on Earth, how life must have formed, because we all know that till now Earth is only the known planet which is supporting life. So first of all, the first point here, the first that we are getting is intelligent designer. That okay, life came by some intelligent designer. God created everything. So this is the first, according to scientists and philosophers, they are saying. Next is primordial soup. In this explanation, primordial soup means that life came from some nitrogen fixation and ammonia. Yeah, that what we say that your proteins formations took place. Okay, amino acids start to build together due to some lightning strike in the atmosphere, and some primordial soup from the primordial soup, a lightning strike suddenly struck the atom of an amino acid and start forming the protein chain, and life is now, as we are seeing, the complex form took place. So it came from a soup type of structure where some lightning struck and it started to form some lumps, and human beings and every living organism formed. Third is panspermia hypothesis. It states that life came from some other place, like some other planet, through some asteroids or comets or like that. They came to Earth from some other place. It did not originated on the Earth, but it came from some other far heavens or like that. The most interesting basically theory is it's my also favorite. That is the last one, that is known as zoo hypothesis. In this, it is told that we all are living in a zoo, and some very intelligent beings, some very big aliens or some extra dimensional things, extra dimensional beings are actually, they have made this earth as a zoo with keeping all the different type of species from other planets and everything on earth, and they are actually we are living in a simulation of these extra dimensional, that higher dimensional beings. So this is zoo hypothesis, that aliens kept us like animals in a zoo, and this is very interesting. Okay, maybe these are all hypotheses. We don't know actual reason. Till now, the support which science support is primordial soup. Okay, nitrogen fixation was happened, protein fixation, and it created all the like complex amino acid proteins. Okay, so this is okay. So let's. This is our last slide. So it is about alien life forms. It will tell us that okay, how alien life forms will look if, like, I'll say if some aliens are there. Here's a video actually. I will play a video in which we will see okay how aliens would look if they are out there somewhere, or maybe on Mars, maybe on Jupiter. Okay, so let me just play this video. Okay, ma'am, let me just play this video. So this is a video.
Voice is coming little slow.
Is it fine, ma'am? No.
Oh, little bit fine.
Okay, so this was our like, it was basically, this slide was saying that maybe aliens will not be like that, in which like the way the movies are showing, like the Hollywood movies
Yes,
and their jadoo.
yes.
They may be looking like some elephant which is having a big span of wings with his ears, and it is only on a planet they are only the main alien forms that we are able to see. So we are just trying to assume that what all types of aliens we can see. Some spider-like creatures on Mars with huge legs, big creatures. Maybe they are present. So they are saying out according to the habitable. They are how they are getting adapted to the habitable conditions there. Okay. So with this, I would like to conclude my presentation. So thank you all for your patience and your interest for astronomy, because astronomy will be like, it is the extent of our imagination, because it is like beyond our imagination. We cannot even imagine what all marvels humans, or what all marvels our universe is actually having. So thank you, ma'am, for this opportunity.
Yeah. Thank you, Pratyaksh, first of all, for sharing such a wonderful presentation with us on our platform. And we also look forward to work in this direction with like more relatable topics in coming future. Also, if anyone has any doubt related to any slide, particular, any questions related to today's topic, you are free, feel free to write to us at planetariumprogram@gmail.com. Planetarium will be happy to serve you best in this direction. Also, if anything you wanted to ask with Pratyaksh related to Science Genie or any specific questions, so we can definitely Planetarium can share the email ID and can forward that questions to Pratyaksh, and Pratyaksh can then certainly answer for that. So I think we'll have a wrap for today's session. We'll end it here. And we really look forward because this is the planetarium's regular uh, program. Every month we'll be doing several online webinars on different topics. So probably we'll be coming back with another topic to discuss more about the astronomy. Thank you, Pratyaksh, for giving your time, for your valuable insight, and we really look forward to work with more on this direction. Thank you, everyone. Have a nice day. Take care.
Thank you, ma'am. Thank you for the opportunity.
Thank you.